Fiber Optics by Lan Nguyen.
Ariel Williams,
Connor Stevenson,
Mohammed Al-Hamid,
Muhammad Sarafi.
Fiber optics are defined as cables that transmit by means of light pulses along a glass or plastic fiber instead of electrical signals over a conductor, ideally suited for long distance. How fiber optics work. Fiber optic cables consist of pure silicon glass cylinders or strands that are typically called the core. The core is surrounded by cladding. The cladding's job is to keep the light signals inside the core. Fiber optics come in two types, single-mode fibers and multi-mode fibers. Single-mode fibers have small cores and transmits infrared laser light. Multi-mode fibers have larger cores and transmit infrared light from light-emitting diodes. A fiber optic cable on a network typically consists of at least two strands. Each strand can pass a signal in one direction, one for sending and one for receiving. Electronic signals generated by the computer are converted to optical signals in the form of photons. The electronic signals are then transmitted down the cable by a laser. A photodetector on the other end collects the optical signals and they are then converted back to the original electronic signal. The information translated is essentially digital information generated by telephone systems, cable television companies, and other computer systems. Fiber optics applications: military, surgery and dentistry, internet connection. Military uses fiber optics on different vehicles because they are lighter, more reliable, and has noise immunity. In addition, fiber optics are utilized by the military on the battlefield since they are hard to damage, tap, or jam.
Fiber optics are used for endoscopy, which is non-intrusive surgical methods. The fiber optics is used within a person's body to light up the surgical area. This technique reduces the number and size of incisions made during surgery. Fiber optics is also used in microscopy and biomedical research.
Fiber optics is also used for faster and more reliable internet. According to broadbandnow.com, typical broadband speeds have become 1,000 times faster in 20 years by a single existing fiber optic connection. In addition, the largest fiber optic providers for the U.S. are Verizon FiOS, Light Tower Fiber, Frontier, Monmouth, Sunassys, Level 3, and RCN and RCN. Meanwhile, the states with the most fiber access are northern states. They are, as listed, Rhode Island, Oregon, New Jersey, New York, Maryland, and North Dakota. BroadbandNow.com also has an interactive U.S. map that displays broadband coverage. The denser areas, such as California and New Jersey, indicate that those states have more internet coverage. Next, by selecting an individual state on the map, such as Texas, you can get further broadband statistics. For Texas, as the snapshot depicts, it is the 46th most connected state in the U.S. In addition, there are also 95 fiber optic providers in Texas. Together, they cover 2,958,351 Texans, which is about 11% of the Texas population. Perhaps, in the future, we will see fiber optics cover more of Texas's internet connection.
The pros of fiber optics: faster speed, more reliability, unlimited bandwidth, further distance, and less interference. The cons of fiber optics: higher initial cost and more maintenance.
Twisted pair is the first alternative to fiber optics. They are insulated copper wires and transport telephone signals. Twisted pair is the most common wired medium. Their pro is that they are a thin and flexible medium, making them useful in apartment and office buildings. However, Twisted pair is a fragile wire that is susceptible to interface. The second alternative to fiber optics is coaxial cable. Coaxial cables are insulated wires with a single inner conductor, usually made from copper, all of which is surrounded by a mesh-like conductor, and then insulated again on the outside. These are used to carry television signals. Their pro is that they are thicker than twisted pair cables, but they are more expensive than twisted pair. However, both are cheaper than fiber optics. Both twisted pair and coaxial cables share several pros and cons. The first pro between both of them being that they are cheaper than fiber optics. The second pro is that they are already in place and still run reasonably well, making them viable options to carry internet connections. However, both twisted pair and coaxial cables are less durable than fiber optics, making fiber optics a better choice for long distances such as across the ocean floor. However, twisted pair and coaxial cable can still be used for short distances such as in your home or in your office.
According to Time magazine, as depicted by the diagram above, Internet users have increased by 800% from 2000 to 2015. Thus, to keep up with increasing consumer and commercial demand, telecommunications will need to rely on fiber optics. Furthermore, by having a widespread use of fiber optics, digital communication services will be faster, clearer, and more reliable. Microsoft, Amazon, and Google Cloud have noticed the increased demand for faster and more reliable internet. These companies and their increased data centers have helped and will continue to help fiber optic firms grow. First, according to Microsoft Chief Technology Officer Mark Russianovic, the company plans to grow from 22 to 28 data centers in 2016. The first two of these new data centers will be in Oregon and Tokyo. Meanwhile, Google has announced on March 22nd that it plans to add 12 new data centers by the end of 2017. Amazon plans to grow from 12 regional clouds to 17 in the upcoming year. Thus, we can see that the future of fiber optics will be very bright. In conclusion, fiber optics currently cost more than copper-based wires. However, future technological advances may make fiber optics cheaper to produce and install. Nevertheless, corporations such as Verizon Wireless and Fiber Tower should continue investing in fiber optics since the demand for reliable and fast internet continues to increase each year.